Ladies and gentlemen, hello. We have made it to another fabulous day. And here we are looking at topic 13, the third section of it, our third day of notes. We are looking at finding the area of regular polygons. Okay, so we start off with a couple of vocabulary words real quick. Okay, the first one is the apothem. Okay, kind of sounds like opossum, except with a th in there. Okay, apothem is that word, and it says that is the perpendicular distance from the center of a polygon to the middle of one of the sides. Okay, so a couple of things. Okay, when we look at this diagram right here, this line that I'm outlining in red, that is the apothem. Okay, you know what? I'll go ahead and do it in purple just to match that word. Okay, that's the apothem. And the radius, we've heard that word before when we talked about circles. This time we're talking about it in terms of polygons. We say that a radius is the distance from the center, that center point, to a vertex. And I'll outline one of those in green. Okay, that right there would be an example of a radius. Okay, so with those two things in mind, we're going to be using the definition of apothem today. We're also going to be using this idea of splitting up a polygon into a bunch of triangles like we have right here. Like y'all can see just right there on the screen, y'all can see that when you draw all those radii, it splits what we have right here, what we have is an octagon, it splits it into a bunch of triangles. Okay? We're going to be using the idea of that to find the area today. Okay? So first off, we look at the number of sides. We have 8 sides on this. That is what makes it an octagon. Okay, the shape that we have right here is an octagon. And so what this series of questions is asking, and this is one of the you've got a couple of questions on your assignment today that are like this. Okay, it's asking what are the measures of some of the various angles that are represented in this picture. Okay, so the first angle, angle 1, is this angle right in here that is made by 2 radii. Okay, so right now we're going to use a little bit of knowledge that we know about circles. Okay, and back when we talked about circles, we said that if you talked about a full revolution and you rotated a radius all the way around, starting right here, and then we brought it all the way around back to where it was right here, that would be a full rotation of 360 degrees. Okay, and we already know that one full rotation is 360 degrees. So what we're going to do to find the measure made by 2 radii here is we're going to just take that 360 and divide it by however many sides there are on this shape, because that is how many equal-sized angles we have. One right there, and right there, and right there, and there, all the way around. All of those angles made between the radii are the same size, and we just do 360 divided by 8. So that means each of those angles, as represented by angle number 1, is 45 degrees. Up next, we're looking at angle number 2. Angle number 2 is this one that's down inside of here. Okay, inside right there. Okay, you might can barely even see it. I'm going to use a darker. There you go, that dark pink right there. That's our angle number 2. Angle number 2 is the angle in between a radius and an apothem. And if we're talking about the angle in between a radius and apothem, we need to know that an apothem splits one of those triangles in half. And if we're splitting that angle in half, all we got to do is take angle 1 and divide it by 2. So that means angle 2 over here is 22.5 degrees, because that's half of the 45 that we just found. Our last one is angle number 3. Angle number 3, if we're talking about angle number 3, we need to figure out that when we look at this, what we're really dealing with here, I'm going to outline it in orange. What we're dealing with here is a right triangle. And we already know that this right down here is a right angle because of the little box. So that would be 90 degrees. We already know that angle number 2 up here is 22.5 degrees. That's what we just found over there. So if we just subtract those things from 180, that would give us our answer for what is angle number 3. Because we just got to remember that every triangle always adds up to 180. So if you just take 180 and subtract those other two, it'll give us our missing angle, number 3, 67.5 degrees. Okay, there are going to be some questions on your assignment that we'll talk about that. It'll give you a picture kind of like this. It'll be different shapes. Obviously, we won't give you another octagon, but it's going to work the same. Those calculations for how you find angle 1, 2, and 3 are going to work the same way. All right, so there's that. Moving on now to finding the area of polygons, okay? Our formula is this right here. Our formula is that the area equals 1/2 times the perimeter times the apothem length, okay? Now there are some problems where you are going to have to find the apothem length, okay? That's what this is on this slide. We're actually going to skip ahead to our next ones where it's a little bit easier to calculate, and then we'll come back around to this, okay? So take a look at this one right here. Remember that your formula for the area is 1/2 times perimeter times apothem. So what this problem gives to us is that we're dealing with a pentagon. So if we're dealing with a pentagon, it's got 5 sides. And it says that we're dealing with a regular polygon. So that means all of the sides are going to be the same length. Okay? So if we're trying to find the things that go into our formula, we need to find the perimeter. Okay? It's going to be 5 times the number of sides times the length of the side, which is 6 times 5. So that will be our perimeter, 30 meters. That's one of the things. And our other thing that we need is the apothem length. Well, look at that. They already gave it to us. Our apothem is 4.1. So that means you can just take 1/2 times the perimeter times the apothem, and that would be it. 1/2 times 30 times 4.1. We cut that 30 in half and then multiply it. You could just punch it into the calculator all at the same time. It would still work the same as long as you've got good numbers. And there's our answer right there, 61.5 square meters. Okay, so if we had a regular pentagon with sides that were 6 meters long and an apothem that was 4.1, you can just plug it in, find the perimeter, and put that into the formula. Rolling on now to our next one. Our next one says that this shape that we're dealing with is a decagon. Okay, a decagon is going to have 10 sides. So with that in mind, when we're trying to find the perimeter, all we're doing is multiplying this number 10 times 5.6, because that's how long one side is. 10 times 5.6 gives us a perimeter of 56 meters. That's going to be important stuff because when we plug that into our formula, it's 1/2 times that perimeter times our apothem length. Remember that your apothem, 8.6 meters. All right. We plug all of that in, cut the 56 in half, and then multiply it. Again, you can put that into the calculator in any order that you want to, and it would still work. Okay. There's our final answer for the area, 240.8 square meters. Okay, I want to come back around now and look at this last problem. Even though it was on the previous page, it's going to be the last one that we do. And I want to look at it because this is one where this is a case where you would have to figure out for yourself, what is the length of the apothem. Okay, so when we look at this shape, we know that we can just count it up and we see that it's got 6 sides. That makes it a hexagon. Okay, and if we're trying to find the perimeter, it's just like those previous problems. We multiply the side length times the number of sides. 6 times 20 gives us a perimeter of 120. Now, when it says find the angles right here, what it means is find the angles that are involved. So if we drew a radius right there to match this radius, Okay, we've got an angle inside of here, and we've got a larger angle that goes in between radii. Okay, if you drew all the radii like we had on that problem at the very beginning, if we drew all the radii like we had at that problem from the beginning, we would need to find all of these angles. Well, each one of these angles, all of those angles in between the radii, are just going to be 360 divided by the number of sides. That means each of those radius angles are 60 degrees. And that means our apothem angle, this one up in here that's light blue, okay, this angle that I'm about to circle right here, that one is going to be half of it. So it's going to be 30 degrees. Okay, so what we're dealing with down inside of this triangle right here, okay, let me highlight the triangle that we're dealing with. What we're dealing with is this triangle. And we know that our apothem length is going to be this side of the triangle, but we also know that this angle is 30 degrees, and we know that this side of the triangle down at the bottom is 10. Okay, that right there is 10 meters because it's half of the side length. This right here is, this one right here, this angle is 30 degrees because it's half of the central angle, half of that radius angle. Okay, so if we do some quick calculations, we can figure out, if we just do a couple of quick calculations, we can figure out that this right here has to be a 30, 60, 90 triangle. And if that's a 30, 60, 90 triangle, then that means the relationship between the short leg and the long leg is always the same. And that's this. The long leg equals the short leg times square root of 3. So if the short leg right here is 10, that means our apothem is 10 times the square root of 3. If you punch that into a calculator, it is equal to approximately 17 meters. Okay, that's our apothem. Okay, so now we've got the two things that we need for this formula. The two things are the perimeter and the apothem. So when we plug them in, it's 1/2 times P times A. And when we plug those in, we end up with an answer 1,020 square meters. 1,020 square meters. All right, take a look at your problems. Okay, on your problems for your assignment today, I want to give y'all a couple of hints. First off, on problem number 2, I want you to go ahead and in your mind draw that dividing line. Okay, what that does for us is it makes it one trapezoid on this side that you find the area of, and it makes it another trapezoid on this side. So use that trapezoid area formula twice and then add them together. Okay, look at your next hint. Is going to be on problem number 3. The height of this thing right here, the height of this thing, okay, look at it. That height makes a 30, 60, 90 triangle. Okay, so when you're finding the length of the base, it's going to be 7, and then this one right here is going to be 2 because it's half of the hypotenuse. And the height is going to be 2 square root 3. Okay, 2 square root 3. On question number 4, that is a kite. I just outlined your diagonals in blue right there. That's what you're dealing with. All right. Questions number 4 through 8 all look to be pretty straightforward. All right, pretty similar to what we did on the problems today. All right, so y'all get after it, and everybody have a good day.